Welcome to my YouTube channel, A Brainery of Civil.
Today I am going to solve the second assignment of matrix methods of structural analysis. Obviously, in the last video I explained it is one of the most toughest topic. So we will see. Okay, I will give some important tricks to remember in this video. Okay, so let's go with one question. First question, which of the figure shall we use to determine the elements of first column corresponding to degrees of freedom number 1 as shown in the structure of the flexibility matrix? That is, he has given one continuous beam. He has assigned himself as coordinate 1, 2, 3. Now, whenever we are going to first calculate first column of a matrix, we need to apply unit displacement. That displacement, either it may be a rotation or deformation at coordinate 1. Okay, and we need to calculate all the forces or moments or reactions developed at coordinate 1, coordinate 2, coordinate 3. Okay, so that is to calculate first column of a matrix. So the first column will become S11, S21, S31. That is, we need to apply unit rotation as coordinate is assigned like it is a rotation, unit rotation, and we need to calculate forces or reactions at coordinate 1, coordinate 2, coordinate 3. And he asked the diagram. So it is a continuous beam. So whenever we rotate like this, so this beam will deform, like it will go down or it will go up. Okay, so the option D is the correct answer. Clear? And next question, how many degrees of freedom are there neglecting the axial deformation of the beam? Okay, so obviously the given beam is a fixed beam. We know degrees of freedom or degrees of kinematic indeterminacy both are one and the same. It is the number of independent displacements at all the joints. I am writing here the number of independent displacements at all the joints in the given structure. How many joints are there? This is one joint, this is second joint. As the displacements possible are delta x, delta y and theta. So here, as the joint A1 is a fixed joint, there is no delta x, that is delta x is 0, delta y is 0, theta is 0. So that is degree of kinematic indeterminacy or degree of freedom at 1 is equal to 0. Degree of kinematic indeterminacy or degrees of freedom at 2 is equal to 0. So the answer will become it is 0. Option A is the correct answer. Okay, so for second question, option A. And now it's one of the question I have given, but I didn't got any proper answer. What will be the equivalent load at joint A? So he asked us to calculate equivalent load. So I am going to solve this method by moment distribution method. So that is MDM method. So first of all, when we are going to calculate MDM, we need to calculate distribution factor. Okay. So first of all, at joint B, and the member will become BA and BC. When far end is fixed, relative stiffness, that is K, will become I by L. L here it is 24. And when far end is hinged, as the end C is hinged, relative stiffness will become 3/4 of I by L is equal to 8. So whenever you get added both these, so whenever you get added, you will get it is 13 by 36. And this 0. So the distribution factor for member BA will become I by 34, I by 24 divided by 13I divided by 36. So this entire thing you will get it is 0.115, and for distribution factor for member BC is 3i divided by 24 divided by 13 by 36. So you will get it here, it is 0.885. Okay, so now I am putting one table. So here it is joint B. On BA it is A, it is C, and the distribution factors are here. It is 0.115, it is 0.885. Okay, so here fixed end moment. So as the end, here it is anti-clockwise, here it is clockwise. It is WL square by 12. How much is W? 2. 24 square divided by 12, you will get it is minus 96. Here it is plus 96, and there is no load on BC. So now at joint B there is a clockwise moment 96. This has to be distributed in the ratio of 0.115 and 0.885. So you will get it is, you need to apply anti-clockwise moment. So you will get it is minus 11.04. So minus 11.04, how you will get it is minus 96, you need to apply that into 0.115 will give you minus 11.14, and it will give minus 84.96. Okay, so when for and D is fixed, the carryover moment will be half of this. So you will get it is minus 5.5. Here this total 96 minus 11 will become 84.96, and this will become minus 84.96. That is equilibrium at the joint. You can see here it is, from this observation, it is at 0. What are all the options? Out of this 24 into 2, the equivalent load here you will get it is supporting load upward 24 into 2 divided by 2, it is 24 upward. So 24 upward, there is no 24 upward is here. Okay, and remaining all downward, upward, remaining other values. And here the moment will become 96 minus 5, it is minus 101.5 kilonewton meter. Okay, so minus 101.5 kilonewton, it is minus means it is anti-clockwise. So there is no option is matching. So in this I didn't have a proper option. Okay, this is way how to solve the problem. And suppose, next question, coming to the next question, suppose a structure has static indeterminacy of 3, that is degree of static indeterminacy 3, and a degree of kinematic indeterminacy is 2. How many redundants should be considered to solve using displacement method of structural analysis? So the main thing in the structural analysis, there are only two matrix methods. The first one is stiffness method, and the second one is flexibility method. Very important, listen carefully. Okay, so it is a flexibility method. Stiffness method, the unknowns are displacements. That's why we call this method as displacement method. Okay, and to calculate these unknowns, we will use some equilibrium equations. That is the another reason we call this is equilibrium method. Okay, D, E, S, D, E, S, and K is one more term. K is the number of unknowns will be equal to degree of kinematic indeterminacy. So dk. So that's why I kept one code DESK. So displacement, equilibrium, and stiffness, all these methods are same, and in all these methods the order of the matrix will be is equal to degree of kinematic indeterminacy. So he asked us to calculate in the displacement method. So the number of unknowns considered redundancy is degree of kinematic indeterminacy, that is 2 is the answer. Answer will be D. Okay, and next question, what is the primary unknown in analysis of a structure by displacement method? Obviously I told just the unknowns are primary unknowns, especially primary unknowns in displacement method is displacement itself. This displacement, either they may be a rotation or deformation. If it is a rotation, it will be theta, deformation it will be delta. Okay, so the answer it will be C option. And now, before imposing boundary conditions, stiffness matrix R, okay, stiffness matrix, Generally, stiffness matrix is a non-singular matrix. We have one equation to calculate forces in all the members. P equal to K delta, where P is in the form of a matrix, K is again in the form of a matrix, delta is again in the form of. So here in the stiffness matrix, the unknowns are deflections or displacements. That is, we need to calculate delta. So when K will go on this side, we need to calculate K inverse P. Okay. So whenever we are required to calculate inverse, it has to be non-singular matrix. That is, A inverse is equal to 1 by mod A into adjoint A. So if mod A is equal to 0, then it is not possible to calculate inverse. Clear? So K has to be non-singular matrix. Non-singular matrix means it is mod K not equal to 0. That is, non-singular is option D. So that is 6th question, answer D. And next question, method of moment distribution falls in which category? All these methods, generally stiffness method has extension of slope deflection method. Okay, slope deflection method. This is extension of moment distribution method, and stiffness, equilibrium and displacements. So these are all same methods. Okay, so moment distribution method will fall in the category of displacement method of structural analysis. Option A is the correct answer. Okay, and next question, in this truss stable, is this truss stable? That is, the given stress is stable or not, he is asking. Obviously we need to calculate degree of static indeterminacy. Degree of static indeterminacy is equal to m plus r minus 2j. So how many number of members are there on the diagram? It is 2 members. How many number of joints? It is 1, 2, 3 joints. Okay, so that is minus 2 into 3 joints. How many number of reactions? Here number of reactions 2, here number of reactions 2, total 4. That is 6 minus 6 is equal to 0. That is, when degree of static indeterminacy is equal to 0, thus given truss is stable and determinate. So he asked us, is this truss is stable or not? Yes, this truss is stable. So option is A. And now, how many number of degrees of freedom to be removed to make the structure statically determinate? To make the structure statically determinate, we need to remove the degree of static indeterminacy. Okay, that is option A. Generally, to make the structure stable, we need to remove as many number of degree of static indeterminacy. Okay, so that is for this question, answer A. And again one simple question, what will be the kinematic indeterminacy ignoring axial deformations? Ignoring axial deformations, the given beam is, we will calculate only the kinematic indeterminacy based on the structure. It is irrespective of the loads. So at A it is a fixed, and at the end it is, this is a roller. Okay, so neglecting axial deformations, that is at fixed joint degree of kinematic indeterminacy is 0. At roller support there will be delta x, that is it can move in horizontal direction, and theta will be there. So as he said, there is no delta x, that is axial deformation neglected. So delta x is equal to 0, only only rotation will be possible. So degree of kinematic indeterminacy will become 1. Option B is the correct answer. So by now I have explained all the questions in the structural analysis. Especially these questions are related to mainly based on the displacement matrix or stiffness matrix. Okay, these are all the most important questions and is one of the most toughest topic in the structural analysis. If you have any doubt and if you require any other subjects, please post your comment in the comment section. I'll upload the related question and answers in detail with perfect explanations. Okay, thank you.